system of linear inequalities. 2.8, remember when we just did inequalities, we were just graphing inequalities. We graphed the line, and then we did the shaded part.
Yeah.
Okay, so and then we did the linear system where we graphed two lines and we found the point where they intersected, and that was our solution. Graphing system of linear inequalities is a hybrid of both of those. So we're going to have two inequalities that we're going to graph. We're going to have solutions that are the shaded areas for both of those inequalities, and our solution is where those shaded areas intersect. So wherever you have shaded twice, that will be your solution. So the system of linear inequalities consists of at least two inequalities. Sometimes you'll have more, but it's for sure two. The solution of a system of linear inequalities is any ordered pair. Again, you might have more than one ordered pair that's a solution, but it's any ordered pair that's a solution for each inequality. So both of them. All right, and then the last vocab term or group of terms is graph of a system of linear inequalities. And that's the graph of all solutions in the whole system, whether you have 2 inequalities or 10 or 20 inequalities. So all of the inequalities that you have in the solution is the graph of linear inequalities is the graph of all of the solutions. And then just as a side note, remember that if you're using less than or greater than, you're using the dotted line. And if you're using less than or equal to or greater than or equal to, you use a solid line. Okay, so you have this on your note sheet, but graphing the system of linear inequalities, I would do it where you graph one line and then the solution, and then graph the next line and then the solution. But you want to, however you do it, graph each inequality and then shade each solution. So again, to find the solution, you're going to pick a point that's not on the line, and if that is a solution, that half plane is all a solution. If it's not a solution, then none of that half plane is a solution. So this, you might want to use colored pencils, or some of you use highlighters, however you want to do it, but just so that it's easy to see where your lines intersect. If you're just using a plain lead pencil, you might want to use different patterns, like swirls or first lines or checkers or checkered print or whatever you want to do, but so that it's easy to distinguish between what's been shaded twice and what has not been shaded twice. Okay, so with our inequalities, we're going to graph each linear inequality. So in this first system that you see, the graph of the system is the intersection of the shaded regions. So we're going to graph one line, then shade it. We're going to graph another line, and then shade our solution area. So the first one, y is less than 2x plus 1. Since this is strictly y is less than, we have to use a dotted line. So we're going to start with y is less than 2x plus 1. We're going to graph it as if it was y equals 2x plus 1. That's how we're going to graph our line. So we're going to start at the y-intercept, which is 1, and then use our slope from there. So up to over 1 or down to to the left one. So here's your first inequality. Now we're gonna find the solution, which half plane is the solution, by picking a point that's not on the line. 0, 0 is not on the line, so I'm gonna pick that point. So is 0 less than 2 times 0 plus 1? Is 0 less than 1? Yeah, 0 is less than 1. So here is our solution for this first inequality. Now we have to do the second inequality. We're going to do the same thing. Graph the line, pick a point, and determine whether or not it's a solution. So with the second one, our y-intercept is -3. So we'll start there. And our slope is -1. So down 1 over 1, or up 1 to the left 1. And because it says less than or equal to, we're going to use the solid line. Now we can still pick the point 0, 0, even though we already chose that for the last one. We can still pick that point because it's not on this line. Okay, so I'm going to do that. I'm going to pick 0, 0. So is 0 less than or equal to -0, which is just 0, minus 3? Is 0 less than or equal to -3? No, it's not. That means this is not a solution. So that means none of this half plane is a solution, which means that this is the half plane that's a solution. Now, just so you can see, I'm going to use a different color. You don't have to do this when you're doing it. But, so my solution for this system of linear inequalities is the section that it intersects, that the shaded regions intersect. So in this case, it's below the solid line and to the right of the dotted line. All right, this next example is about a system with no solution. So you only have a solution in the system if the shaded regions intersect, if they overlap. So let's look at this next one, graph a system with no solution. The first one, we're going to use the solid line because this is y is less than or equal to. I'm going to start with my y-intercept, which is 1, and then I'm going to use my slope. I go down 3 units and over 4. So here's my first line. Okay, and then y is less than or equal to -3/4 x plus 1. I can choose 0.00 because it is not on my line. So I'm going to do that. Is 0 less than or equal to -3/4 times 0 plus 1? So is 0 less than or equal to 1? Yes. Yes, it is. So use my highlighter. Blue here. Alright, so here's my first solution for my first inequality. Now for the system, my solutions have to overlap. So now I'll graph my second one. So my second one is in standard form. You can put it back into slope-intercept form if you want, but you could just graph it in standard form, which I think is just as easy. So we're going to graph using the x and y intercepts. So the first one, we'll do the y-intercept first because it looks easier, but it doesn't matter which one you do first. So 4y equals 16, y is 4. So my y-intercept is 4. My x-intercept is when y is 0. So 16 divided by 3, which is 5 and 1/3, which is just a little bit off my graph, but you can estimate. And for this one, since it's just 3x plus 4y is greater than, I have to use dotted line. Okay, and then I can pick again 0, 0, which is especially easy when it's in standard form. So 3 times 0 plus 4 times 0. So is 0 greater than 16?
No.
No, it's not. So I'm going to use my highlighter. I'll use purple. So 0, 0 is not a solution. That means none of them have claim as a solution. So my solution for the second inequality is above the line, which if you look at the graph, you can see that at no point do those solutions intersect. That means that there is no solution for the system. Even though there's a solution for the first inequality here and a solution for the second inequality up here, there's no solution for the set, the system. So we can say no solution. So here's what your lines should look like if you graphed those. Make sure, just double check, make sure that your lines actually look like mine do. If you take, oops, I thought I had a highlighter. All right, if you take this first equation and you put it into slope-intercept form, you're going to get the same slope. Okay, so with this next one, they should be parallel. Mine look a little off, but they should be parallel. You end up with the same slope of 1/3. Okay, so let's look at the first example. Y is greater than 2x minus 3. Did you shade the left side or the right side?
Left.
First example to the left. Yes, you should have shaded this left side. Use this pretty highlighter. Okay, for the second one, y is less than -1/2 x plus 2. Did you shade the top or bottom? Bottom.
Oh my god.
All right. So your solution is that reddish area. Alright, in the second example, for your first inequality, -x plus 3y is greater than -6. Did you shade above or below?
Above.
You should have shaded above your dotted line. Alright, so this is your solution. And what about 1/3 x plus 1? Above or below? Below. Alright, so your solution again is that red region. So here we're going to graph y is less than or equal to 4, which is just a horizontal line. So graph that on your note sheet. Horizontal line at y is 4 with a solid line. And the absolute value one, remember absolute value equation? Okay. Our h value is the x coordinate of our vertex. Okay, so your absolute value inequality, we need to start with our vertex. What's our vertex? 2, 1. 2, 1. Not -2, 1. Positive 2, 1. Okay, so graph that first. The vertex 2, 1. Then I usually pick a point right next to it. Some of you graph using the whether or not it has a vertical stretch. You can do that too. But I just would pick point 3. So 3 minus 2 is 1. Absolute value of 1 is 1. 1 plus 1 is 2. So 3, 2. And then I would graph the symmetry point. Okay, now again you can use point 0, 0. So first of all, for y is less than or equal to 4, you don't really need to pick a point. You can see that any of these values are less than 4. Any of these y values are less than 4. You don't really need to pick a point for that. You can if you want. 0 is less than 4. Yes, it is. And then for the absolute value, you can pick 0.00. So is 0 greater than 0 minus 2 plus 1? Make a 2. Absolute value of that is 2 plus 1 is 3. Is 0 greater than 3? No, it is not.
No.
What about a 10? What about
So here is your solution. Alright, this next problem is a story problem, and it says that we're selling pizzas to raise money for a school field trip. Cheese pizzas cost $8, and pepperoni pizzas cost $9. You need to sell at least 2 of each pizza, and you want to sell at least $150 worth of pizzas. So the first step of this is to write inequalities so that we can graph the system. So to write the inequalities, first we want to think about the information that we know. Okay, cheese pizzas cost $8, pepperoni pizzas cost $9, and we need to sell at least 2 of each pizza. So let's say for X is the number of cheese pizzas, and Y is the number of pepperoni pizzas. Okay, so with this, we need to write an inequality related to X and Y. So if we want to sell at least 2 of each type of pizza, then our X has to be greater than or equal to 2, and our Y has to be greater than or equal to 2. All right, and then with the information that they gave us, we have at least one other thing that we know. It says that we want to sell at least $150 worth of pizzas. So if our X is the number of cheese pizzas, and Y is the number of pepperoni pizzas, what inequality can we write to talk about the money that we're going to make from these pizzas? So each cheese pizza costs $8, each pepperoni pizza costs $9. So 8x plus 9y, that's the profit from the cheese pizzas plus the profit from the pepperoni pizzas, has to be greater than or equal to $150. So now that we have our 3 inequalities, this is our system of linear inequalities, we need to graph those. So I used a scale of 2 on this grid because that's what works for this data set. So depending on the data set you have, you might have to use different scales, but this one works for if you use 2. So the first inequality, X is greater than or equal to 2. So here, and actually this should be a solid line. So here are all the values where X is greater than or equal to 2. And then our second inequality is Y is greater than or equal to 2. So here are all the places where Y is greater than or equal to 2. So I'm going to shade my solutions. So here's all where Y is greater than or equal to 2. My blue highlighted region. And my purple highlighted region is going to be all the areas where X is greater than 2. And then lastly, I need to graph that last inequality where 8x plus 9y is greater than 150. Since this is already in standard form, I'm just going to solve with the x and y intercept. So 8x solve for x by dividing both sides by 8. And if I do that, I get an x-intercept of 18.75. So I'm going to graph that. I'll use a green line. So it's about here. And then I'm going to do the same thing with my y-intercept. 9y equals 150. So that's 150 divided by 9 gives me 16 2/3. That's my y-intercept. So that's about right here. And I'm now going to connect those 2 points to form my line. Great, and then I'm going to shade my last section. And if I use, again, 0, 0, 0 times 8 plus 0 times 9 is 0. Is 0 greater than 150? No, it's not. So here I'm graphing above my line. So you can see the actual solution here. It's the part that's been shaded all 3 times. So just to kind of highlight, this here is my solution. And all of this area here is my solution. So you can try example 5 on your own for extra practice. And then if you have questions, we can go over that in class next time I see you. But otherwise, your assignment is 3.3 from the assignment guide. Thanks, girls. All right, so the first step of this is to write your inequalities. It says that x is the pH level and y is the temperature. So with this information, you can write inequalities where x has to be between 8 and 8.3. So that's a compound inequality. X is greater than or equal to 8 and less than or equal to 8.3. Y has to be between 76 and 80 degrees. So y is greater than or equal to 76 and less than or equal to 80. And then you can graph both of those, well, actually all 4 of those lines. So both lines for both inequalities. So for the first compound inequality for x that I did in green, my solution for this would be the area between here. So it's greater than 8, but less than 8.3. And for the y values, the temperature, it has to be greater than 76 and less than 80. So my solution is where those two where the solution for each of those compound inequalities meets. So it's greater than 8 and less than 8.3 for the pH level, and less than 80 but greater than 76. So just to kind of highlight, this area here in yellow is my solution for the system. So I actually have 4 inequalities. I mean, I have 2 compound inequalities. So that's 2 lines for x and 2 lines for y. So if you want to write them all out, you can do that. But you should also combine them in your final answer. If it asks to write the inequalities, combine them to form compound inequalities. So please let me know if you have any questions. And we can discuss those during class time. Thanks.